All right, so I wanted to go over some of the code for my project and take a look at the save system and how that works. So to start off with, here we're looking at the savable interface. So this is the interface that all our objects that we want to save will implement. You can see it declares two functions. So there's the save data function and the load data function. So when the save system goes to save the game, basically it's going to find all actors on the map that implement this interface, the savable interface, and it's going to call their save data function. And when it goes to load the game, it's going to do the same thing but call their load data function, which passes them a savable data struct, which we define up here. So this is the savable data struct, and as you can see, it just has some simple information. So transform information like the object's location and rotation, and whether or not the object is active. So for example, if we had an enemy that was killed, when we go to load the game, we want to make sure that enemy is still inactive when we load the game. So now I'm going to take a look at the actual save game object here. So this is the object that will actually hold our information. So this is like the save file. And as you can see, we have a savable data map. So this is a map containing all of our information, all of our savable data structs for each actor. So we find the information by that actor's unique identifier. So it's name, basically. Here we have the save slot name, so this is basically the name of the file, the save file. So taking a look at the actual save system itself. So the save system is actually an actor. And the reason for this is so that we can place it in a level, and mainly so that we can define a custom save slot name for each level. So for example, here we have this level is called level 1, so we would have a save file for level 1. If we had a level 2, that would be, we could call it a save file called level 2. And even if we have other game modes, so for example, if we had a party game or something with lots of different game modes, we can have different save files for each one, and it won't matter. So heading back, so this is we start off with the initialize function. So the save system will be initialized by the save system interface. So in this case, our game mode implements the save system interface. So the game mode is going to call initialize on the save system and pass the save system a pointer to itself, which it will store. And then it's going to call load saved game. So head on down to load saved game. And basically what this does is it just calls async load game from slot. So this is an asynchronous call, so we don't know when it's going to finish. And it's going to load the game from our custom save slot name. And once this is finished loading, it's going to call our load save callback. So here, we are going to get a pointer to our save game object. So we're going to cast that to our checkpoint save game. So that was our checkpoint save game, the save game object that holds our savable data map. And we are going to call load all savables. So this is where we're going to go through and find all objects on the map that implement that savable interface, and we are going to load their data. And then we are going to call load checkpoint on the save system interface. So in this case, that is the game mode, and we're going to pass it a pointer to our loaded game. And I will take a look at the save system interface in just a moment. After doing that, we're going to call initialize checkpoints, and this goes through and initializes all the checkpoints on the map. And we will also take a look at our checkpoint in just a couple moments as well. So this is our load all saveables function. This is where we go through and we find all actors that implement the savable interface. And once we have all those actors, we are going to go through our savable data map and see if we have data for those actors. And if we do, we are going to call load data on that actor. And we are going to pass it its savable data. And here we have our initialize checkpoints function. I will go over that in just a moment. But first, I'm going to take a look at our save system interface. So this is the save system interface. This is, in this game's case, the interface that's implemented by the game mode. And as you can see, it just has two functions. It has a save checkpoint function and a load checkpoint function. And this is where we pass it a pointer to our save game object. And I will go over why in just a second. So I'm going to take a look at our game mode. So this is the game mode that implements that interface. So everything that is a part of the checkpoint system is in its own folder. So none of this interacts directly with the rest of our game, basically. It's a generic system, so you can use it in any game. And the way they communicate is via this interface. So the VertiScape game mode, as you can see, implements the save system interface. And we have our two functions, our save checkpoint and our load checkpoint. And taking a look at those. So this is our save checkpoint function. And basically this is called when the player hits a checkpoint. And the reason the checkpoint doesn't just make a call directly to our save system and instead goes through our game mode is because we want to give the game mode a chance to implement its own custom logic and save its own custom data that is unique to that game mode. So as you can see, here we have a VertiScape save game object, and basically this is a custom save game object that inherits from our checkpoint save game. This is so that we can save additional information for this game mode that we don't automatically save with our checkpoint system or our save system. So in addition to all the savable actors, savable data, so their locations and whether they're active, we also want to save some other information. In this case, I'll actually take a look at the VertiScape save game. So as you can see, it inherits from the checkpoint save game, and it also has some custom information. So we want to save the number of collected coins for this game mode, the current game time, and the best game time. So this information is unique to this game mode. So we create a VertiScape save game object. We save its information, and then we call save game on our save system, where we pass the save system a pointer to this save game instance. And because it inherits from checkpoint save game, we can do that. The save game only cares that it, or the save game system or save system only cares that it gets a pointer to our save game. So next we're going to look at the load checkpoint function. So this is where we pass the save system interface, the game mode, a copy of our save game instance, and we cast that save game instance, so the checkpoint save game, to our custom VertiScape save game. And if that's successful, then we can get our custom information. So the number of collected coins, the current game time, best game time. And if you recall, this was called by our save system in the load save callback. So once we get our loaded game data, that's when we call load checkpoint on our save interface. So that's pretty much that for that. Next, I'm going to look at the checkpoint. So the checkpoint is fairly simple. Basically, when we trigger overlap, so on trigger overlap, first we check to make sure whichever actor that triggered the overlap is a player, because we don't want random NPCs triggering checkpoints. So then we check to make sure our checkpoint is active, and if it is active, we disable the checkpoint so that we can't keep going over the checkpoint multiple times, and we call save checkpoint on our save interface. So that was what we just looked at, the game mode in this case. We'll call save checkpoint. So heading back to our save system, I'm going to take a look at the initialize checkpoints function. So this is where we initialize all the checkpoints. So once we have our loaded game data, we call initialize checkpoints. And the way this works is our checkpoints are actually savable actors. So they also implement savable interface so that we can save whether or not they're active. So when our save system goes through, gets the save data, then it's going to go through each checkpoint on the map and say, are you active or not? If it is active, it's going to be enabled. So we're going to call enable checkpoint on that checkpoint. And if it's not active, we're going to disable this checkpoint. And that is how we save which checkpoints have been hit already and which ones have not. Yeah, so that is pretty much the save system. So it works pretty well. Some of the kind of limitations of the save system, of course, the main one being the way we use a map. So the map looks up basically all the actors on the map. So in the level. So when we call load, when we go to load the game, we're going to look at all the actors that are already on the map and see if we have data for those actors. And then if we do, we load their data. This doesn't work very well for objects that are dynamically loaded or spawned in. So for example, if we spawned an enemy in the middle of the level, through gameplay, it wouldn't really matter if we saved their data because they won't be there, if we were to reload the game. So you're not going to be able to find them on the map to load their data. So this works well for static objects or objects that are already in the map. So for example, pickups, or if you had level objects like a door that a player had somehow opened through maybe a quest or something, and you wanted to save that this would be good for that. But it doesn't work very well for dynamically loaded objects or anything that was spawned in dynamically. But yeah, it's a pretty simple little system. It's generic, so you can use it in any type of game. Again, anything that's in this checkpoint system, they don't interact directly with anything outside of the checkpoint system. So it all communicates via interfaces, and I think it works pretty well. So that was the checkpoint system. Thanks.